Good morning to all of you, and welcome to Unacademy JEE English. And today we will be discussing the lecture 5 of Continuity and Differentiability. Okay, guys. So this is brief introduction about myself. You guys might be knowing me now, and this is obviously you can take the Unacademy subscription where you can obviously have live classes, interact with the educator, take live polls and leaderboard, and also test series analysis. There is also going to be live doubt clearing sessions. So if you are staying tuned to the Unacademy app and if you take the plus subscription, definitely there is a lot to learn from, because across India the best teachers are going to teach. And if you like my course, and if you like my teaching here in YouTube, and if you like my special classes over there, definitely you can go to the plus section, subscribe to the IIT JEE goal section, and then obviously if you get the subscription, you use my code, you will be getting 10% discount, which is a heavy discount. Okay, so guys, after that, obviously you can also go into the Telegram app and follow us over there. We will be giving you live updates and a lot of things over there also. So please guys, do join us on Telegram. And good morning, hello Raj, good morning to each and every one of you, and welcome to this session on continuity and differentiability. This is going to be fifth lecture, and today we are going to do 3 or 4 problems on continuity, and then we will move on to the differentiability as well. So guys, good morning everyone who have joined the session, and let's move ahead and try to solve some problems on continuity. So guys, this is a one important question which we have at the moment, which is very interesting problem also. So here they have asked us signum of x is f of x, and g of x is given as x into x square minus 5x plus 6. Okay, so what we have to do is we have to check that the function is discontinuous at how many points. Okay, hi Srinivas, hi, good morning. Good morning to each and every one of you who have joined the session. Today we are going to wrap up continuity, and then we will be moving on to differentiability. This is the 5th session. Hi everyone. So guys, obviously everyone knows the graph of signum x, right? So if I draw the graph of signum of x, it is going to be like this, right? So just after 0 it is 1, and just before 0 it is minus 1. Hello Bindas. So guys, what happens is at 0 we say that signum of x is sgn x. Sgn of x is discontinuous at x equals to 0, right? So sgn x is discontinuous at x equals 0. So what will be sgn? Now f of g of x, that is composition function, right? So we will obviously bring in place of x g of x. So what is that going to be? F of g of x has to be sgn signum of what? X into x square minus 5x plus 6, right? So signum of something was discontinuous when something was 0, right? Treat that x as something. Good morning Sindhuja, good morning everyone. So guys, signum of something is discontinuous when something is 0. So this signum of this thing, right, this thing will be discontinuous when this whole thing is 0. So we just have to equate x into x square minus 5x plus 6 as 0, and the values of x which we will get will be the points of discontinuity of that particular function. Okay, so we'll say that x is equals to 0, right? Or you can say x square minus 5x plus 6 equals to 0. Product of two things is 0, either first is 0 or second is 0. So here if you factorize, you will get what? X minus 2 into x minus 3 equals to 0. So that is going to be x is equals to 2 or 3. So guys, this function will be discontinuous at 2, 3 and 0. Yes. Okay, so if you say this is function will be discontinuous at exactly 3 points. Okay, Got it? Hi Harshu. So if I say guys, signum of sin x, if I say signum of sin x, that will be discontinuous at how many points? Anyone? Signum of sin x? Infinite points, right? Yes. And a signum of sin x. So when is sin x 0? At n pi. X is equals to n pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, minus 2 pi, every integral multiple of pi. So signum of sin x will be discontinuous at every integral multiple of pi. Isn't it? So signum of something is discontinuous when that something is 0. That's how we actually solve the composite functions question. Okay guys, chalo, let's swiftly move on to the next problem. This is a problem guys, come on, take your time. This was asked in mains 2017 and we'll be attempting few mains problems now and then we'll quickly move on. We have discussed, do watch my last video guys, that was an amazing lecture on advanced level problems. Last lecture was totally, we had discussed a lot of advanced level problems and definitely you can go ahead and watch that video, which was the lecture number 4 on continuity and differentiability. So guys, here we have to obviously value of k for which this is continuous. Okay, that means if a function is continuous, I have told you again and again, your LHL will be equal to RHL will be equal to f of a, right? Okay, so here we have to check at x equals to pi by 2, right? Because there is a chance of breaking at that particular point. The function is breaking before pi by 2, after pi by 2, right? So obviously you need not calculate LHL, RHL separately because both will be same because they have the same condition, right? They have the same condition. So you have to simply equate your limit to f of pi by 2 and f of pi by 2 is already given as k plus 2 by 5. Let's see. Fantastic, Harshu. Very good. That's the correct. Hi, Anand. Namaste. Namaste. So, guys, obviously, limit we have to calculate, right? So, what will be that? Yes, Harshu. Very good. So, that will be limit x tending to pi by 2 of 4 by 5 upon tan 4x. 4 by 5 upon tan 4x upon tan 5x. So, guys, which form is it? Which form is it? At the moment, I can very well see that this is a number which is less than 1. And here we are getting what? If you put pi by 2, what are you getting? Tan 2 pi, right? Tan 2 pi. And it is tending to tan 2 pi and divided by tending to tan 5 pi by 2. Now, it is not exactly tan 5 pi by 2, guys, because we are studying limits. It's tending to that value. So tan 5 pi by 2, if you tend towards that, it will be obviously going towards what? Infinity, and this is going towards 0. So it is what? 0 by infinity kind of thing. So which will be again what? 0 into 0 kind of thing. So the numerator is tending to 0 only. Isn't it, guys? The numerator means the power, the exponent. Right, everyone? So the exponent is tending to 0. Isn't it? So it will be simply what? 4 by 5 power 0. Sometimes JEE plays with you. It gives you a complex equation, but that is not indeterminate. So you just have to put the value and you will get that one. As simple as you get it. Right? So you will equate this limit 1 to k plus 2 by 5 and you will get k as 1 minus 2 by 5 and that will be simply 3 by 5. Fantastic, Harshu. Understood, guys? Very standard problem and very basic. So you have to understand first where the function is tending to. Don't simply apply L'Hospital. Don't simply think that we have to take log. Don't memorize things. Understand when are we taking log, when are we differentiating, when are we using L'Hospital. These are very, very fundamental concepts. And if you've not seen my videos, please go back and obviously watch all my videos. Now there's a playlist available for limits, continuity and differentiability, guys. So you can watch that from the beginning. Okay. Now, everyone understood? Anand, Sindhuja? Okay. Okay. Now let's move on to this problem, guys. This is again a very good problem asked in mains 2012. JEE Mains 2012. Okay. That was called as IIT back then. This is the last time AI Triple E was given. So I was the last batch who gave this AI Triple E 2012. Okay. So I gave this thing, and I cannot remember this question then. That what did I do with it? Come on, guys. A very standard problem. Think about it. It's not difficult. I'm giving you a minute. Try this. So guys, after doing these questions, we are going to today start with differentiability also, which is again a very good concept. And obviously a lot of people are confused with differentiability. And yes, if you are in 12th grade, definitely please stay tuned till the end. And because we are going to learn what actually is differentiability, and we will obviously solve some problems on that also. So guys, concept should be clear, crystal clear. Then only obviously this thing will be easy. And obviously continuity and limits will again be used, because differentiability is nothing but limits again, just like continuity. It is just the extension. So if your limits is strong, I guess you won't have any problem. Hi Sabrish, good morning. So guys, what have you done in this problem? So guys, it is not a very difficult thing. So see, we are seeing pi outside, right? What happened, Sabrish? So obvious means like because here this is cos of something, right? So what will happen is, you can send this inside. What will happen? This will become, my f of x will become what? Box of x into cos of, can I say cos of, hi Sharath. So the thing is guys, what will happen? It will be what? Pi by 2 will be multiplied with 2x, right? So can I say it will be x minus 1 into pi, 1 by 2 into pi. This is an angle. So can I say guys, my f of x is nothing but box of x into cos of pi x minus pi by 2. Okay. Sharath, just check your answer once. Pi x minus pi by 2. Now pi x minus pi by 2 means, can I write guys cos of minus theta as cos theta? Because pi by 2 minus pi x will look better, isn't it? Because cos of minus theta is equals to cos theta, because fourth quadrant cos is positive. So let's write it in that manner. So what I'll do is, I will write this as f of x as box of x into cos of pi by 2 minus pi x, right? Because cos of minus theta is cos of theta. Now Sindhuja, that's the very interesting problem. See guys, the thing is, wouldn't it become box of x? What is cos of pi by 2 minus theta? Can I say sine pi x? Right? Isn't it box of x into sine pi x? Right? So guys, the thing is, remember yesterday I solved a question on box of x into sine of something was there, x minus 5, and I told you that will be what? Discontinuous at all the integers. So what we will do is, we will make this as 0, right? We'll make this as 0. But here you analyze this guys, whenever is this box of x discontinuous? At integers, right? At integers box x is discontinuous, and sine pi x at integers will be what guys? Like sine pi, sine 2 pi, sine 3 pi, sine 4 pi. What is happening with that thing guys? At integers what is happening? This thing is becoming 0 guys, isn't it? At integers, isn't it? So at integers this problem is solved. Obviously box of x is discontinuous, yes we know that, but sine x at that point is becoming 0. So discontinuous into 0 will make that continuous, isn't it my dear friends? What a wonderful question here. Can you understand the like the meaning of this question, and did you get this thing? Actually this would have, if I suppose I would have told box x into sine x. Let's suppose this was your question. Box x into sine x. So then we would have told, okay, at integral points, this is nothing but non-continuous, that is discontinuous, but this is making it 0. So obviously this whole thing will become continuous. So only issue was integers, right? Only issue was integers, but at integers this is becoming 0, which is automatically removing that bad guy. Remember, bad guy is making the good guy bad. So the good guy over here is making it 0. He's powerful. He's got some now powers to make him 0 at the points where he's becoming bad. So that is why here this function will be f of x is continuous for every x, for all x belonging to all real numbers. Got it? Okay. If you want to look at the graph also, guys, you can look at the graph. So the graph of this function would look like this. See, this is the graph of box of x into sine pi x. See here what's happening? See this is everywhere continuous, isn't it? Look at the integer points. At integers, LHL equals RHL. See, the graph is not breaking. Is the graph breaking? No. And see, at 1 also the graph is not breaking. Yes, we can see a sharp kink. We can definitely see a sharp kink, but then it is not breaking. It is 0. See, all integers the function is 0, right? But the graph is not breaking, my dear friends. The graph is not breaking. Got it, everyone? Yes, it's like a heartbeat fluctuation, you can say that. Okay, see here, this is such a wonderful graph, right? Box of x into sine pi x. Okay, so it will be 0 at integers, but it would not break anywhere. The graph won't break, so it will be continuous. Fine, everyone? Okay, so that is why the answer to this question is continuous for all real x. Okay, guys, chalo, let's move ahead with the next question. Last question, guys, on continuity, then we are going to move ahead with differentiability. Again, a very standard problem, guys. This is not a difficult one by any means. So guys, you've got 1 minute for this. Quickly get me the answer. This was asked in JEE Mains 11, and this year actually the paper got leaked. Okay, 11 also has a very good story. 2011 JEE Mains paper was leaked all across India. So it was conducted for the first time 2 times. So the guys who reached the center found out that the paper has been leaked. So in between the paper only they were asking them to leave. So they had to leave the paper. Okay, my seniors. So guys, what is happening over here? Tell me. If you look at LHL and RHL, obviously we have to calculate both and equate them to Q, right? So it's a very standard question, guys. What will be LHL? Quickly tell me, guys, come on. LHL will be limit x tending to 0 sine p plus 1x plus sine x upon x. So it's a 0 by 0 form, right? It's a 0 by 0 form. You can differentiate because sine 0 plus sine 0, 0 by 0. So if you differentiate it, you will get what? Limit x tending to 0 cos. So p plus 1 into cos of p plus 1x plus cos x, right? Upon 1. Okay. So guys, what is happening? It is again, now the 0 by 0 form has been removed. So what we will get? X is, if you put x as 0, you will get 1. And this will be 1. So p plus 2, isn't it? So LHL is what? P plus 2. LHL is p plus 2. Right? Now, p plus 2 is equals to q. Okay? P plus 2 is equals to Q. So guys, obviously in exam you can try to subtract both and you should get -2. So then you can obviously see that option checking also, but it is not that difficult to calculate the RHL. So RHL will be, so LHL we got as P plus 2. How P plus 2? Because I just substituted x equals to 0 over here. So cos 0 will be 1, 1. So P plus 1 plus 1, P plus 2. Okay. Now this is what? Root of x, root of limit x tending to 0, RHL. Now I am calculating RHL. That is limit x tending to 0 root over x plus x square minus root x. X plus x square minus root x by x power 3 by 2. So guys, it is a very easy standard limit. So what is it? Tell me. Obviously it is 0 by 0 form, so you can take the root x outside, right? So you can take root x common. So if you take root x common from this, what we will get? If let's suppose you take x common, 1 plus x, right? And minus root x upon x root, you can say root x into x power 3 by 2. So what will happen? Root x common into under root 1 plus x minus 1 upon root x into x. So this is cancelled. So limit x tending to 0. So now what will happen, guys? Simply it is now limit x tending to 0 root of 1 plus x minus 1 upon x. Initially if you differentiate, it will be really cumbersome, very difficult, right? And to differentiate this kind of function. Now it is again 0 by 0 form. Now you differentiate it. So now it will be what? If you differentiate, or else you can divide, whatever you like to do, you can do that. So it will be what? 1 upon 2 root 1 plus x, root of something differentiation, minus 1 upon 1, and limit x tending to 0. So you will put x as 0, you will get 1 by 2. Right everyone? Not a difficult one, isn't it? And I hope you guys know the differentiation of cos theta. Cos of 2x is cos 2x, sin 2x is cos 2x into 2. Yes? Thank you, Anand. Okay. So guys, what we'll get is P plus 2 has now come out to be equal to, P plus 2 has come out to be 1 by 2. So P is coming out to be what? Half minus 2. That is going to be what? Minus 3 by 2. Right? So, and what about Q? Q is half. Because P plus 2 will be equal to, P plus 2 will be equal to what? Yes. P plus 2 will be equal to what? Half. And that also will be, Q is also going to be half. So that is what our answer is. Because LHL equal to RHL and is equal to F of A. Yes. Understood, guys? So these are very, very basic standard problems asked every year in mains. Okay. You can expect these questions in bulk. Okay. Chalo, guys. So now without wasting any time, let's begin with differentiability. So guys, first I would like everyone to just understand the concept, because here is a function, here everyone goes wrong. Okay. Most of the students go wrong. So I would just recommend that please try to understand the concept. So firstly, what is the standard thing about differentiability is a function is differentiable if first of all the graph is continuous. So first of all, a function to be differentiable, it has to be continuous. It has to be continuous and smooth. Okay? And smooth means what? It should not be what? Having a bend or a sharp point. Smooth means what? Not sharp. Okay? Not sharp. No kink like that. Okay? Nothing like that should be there. That means smooth. No edges. Fantastic, Sindhuja. Another definition. No edges. Like sin pi x graph we did, right? So let's suppose if we have just done sin pi x, guys. Okay, so if you see this graph, so this we will say that it is non-differentiable at integers, because you are getting what? Edges, isn't it? You are getting corners. I'll explain you why also. No doubt about it. Don't worry. So there you can see the sharp point at 0. Okay, others it is smooth. Okay, so you will get to know that at this point, obviously there's a sharp kink, so it won't be differentiable at that point because there was an edge over there. Okay, now try to understand what actually is this. So we will try to understand what actually differentiability, how can we derive mathematically. Now conceptually we've understood that there should not be a sharp point. Now why not a sharp point? Try to understand. So guys, I will come to that point also 1 second. So see guys, differentiability means differentiability means unique tangent. Now I'm trying to derive that no edges thing or no corner thing or no sharp point thing into mathematical terms. So that I'm saying is unique tangent. Unique tangent means what? Try to understand. That unique tangent means, guys, that let's suppose if I have got a graph like this, okay? So guys, if I just look at this point x is equals to a, so before this the tangent will be this, and after this line only will be the tangent. So just before and after this point we have two tangents. What is happening? Two tangents. If you look at one more graph, let's suppose like mod x, we'll discuss that. So what is happening, guys? Just after x is equals to, add x equals to 0, just after this, guys, we are having this tangent, and just before this we are having this tangent, because line ka tangent is line itself. So at a particular point I am getting how many tangents, guys? Two. Just before and just after I have got different tangents. That is where the sharp point is created, and that is why we don't call that function differentiable at that very point. Okay, so there should be a smooth tangent over there. So this was mathematically, we understood the concept. Now how to write it mathematically? Let's see. So guys, let's suppose I have got a curve y is equals to f of x like this, and I have got a point p, q and a respectively. So I am testing the continuity at point, let's suppose a. So guys, if I look, let's suppose h is a very huge number, it is like 3 4 5 6 whatever. So obviously the a plus h will come out here, and at that point there will be a different function value that is called as what? F of a plus h, obviously, no doubt about it. This point is what? A comma f of a, right? This is a comma f of a. Okay, so guys, what I'm saying is, at the moment this pa is a secant. What is it? This pa is secant. Okay, similarly qa, this is what? A minus h comma f of a minus h. So this is also what? A secant. So there are two secants out here, right? Because there's secant means also you can say chord for the time being, right? So if I ask you the slope of the chord, guys, what is that going to be? You know very well, y2 minus y1 upon x2 minus x1, right? So slope of chord pa, slope of pa, you will write as what? y2 is what? F of a plus h minus f of a, right? y2 minus y1 upon x2 minus x1, that will be a plus h minus a, right? So guys, this is giving us the slope of chord. What is it giving us? Slope of chord. Slope of chord is like, if you relate with physics, that is actually, guys, nothing but average velocity, है ना? Average velocity, you do what? y2 minus y1 upon x2 minus x1 only. You do delta s by delta t, don't you do it? Right? Slope of chord means, slope of chord you can relate with what? If you plot, let's suppose if you're plotting displacement with time, so that is what? Delta s by delta t only, right? And that is nothing but y2 minus y1, this is delta s, and this is delta t means x2 minus x1, right? So that is nothing but slope of chord. Similarly, slope of secant, that is qa, also will be coming as what? You can say f of a minus h minus f of a. So that will be what? F of a. So I can just see here. So slope of secant, guys, right hand secant is coming as this, right? And left hand secant will be like this. And because y2 is, let's suppose, a minus h. So this will be what? F of a minus h minus f of a divided by what? A minus h minus a. So a will cancel, and that is why we are getting a minus h over here, my dear friends. Okay, now this was secant, because this was what? You can compare with average velocity. This was also what? Average velocity. Now guys, I am talking about, let's suppose this h is tending to 0. It is very close to x is equals to a. So let's suppose it is near, very near. This h is now tending to 0. Now guys, in mathematics, I have told you in the limits chapter, hi Sulachna, h tending to 0. Obviously, h is a positive quantity. I have told you, positive quantity. And what is that quantity approximately? What is that positive quantity approximately, guys? 0.000001. That is always positive. So guys, we can definitely say that a minus h, this will be obviously left hand side, because I have assumed this h to be positive, my dear friends. Yes. And this is obviously a plus h will be slightly more than 0, slightly more than a. That is why slightly more than. So that thing, that chord will actually become what, my dear friends? That will become a tangent, right? Because if you go closer, it will be what? Tangent. This actually, the graph of it won't look like a chord now, because that thing is what? It's happening what? Like f of x was like this. It was a chord or a secant, then it comes closer. Then finally one day it will be very close, so that you cannot actually tell me the difference. So that is why a is here and a minus h will be very close, and similarly a plus h will be very close. So in that scenario, if you calculate the slope, that becomes right hand derivative and left hand derivative respectively, because now the chord or the secant has become a tangent. That has become a tangent, because tangent just touches the graph, and slope of tangent will be this. This is the right hand tangent slope, this is the left hand tangent slope. And this you can relate with, guys, limit delta t tending to 0, delta s by delta t is ds by dt. Remember physics, 11th grade physics, है ना? That is nothing but differentiation, ds by dt, right? And this gives you instantaneous velocity. So this is, you can relate with instantaneous velocity, and this also is nothing but instantaneous velocity, isn't it, guys? And obviously both the instantaneous velocities should be same, right? Both the instantaneous velocity should be same, then only we will say instantaneous velocity is there, isn't it? That means, can I say limit should exist? Am I not saying LHL equals to RHL? Are you getting my point? The limit should exist. So I am saying that obviously both the right hand derivatives and both the left hand derivatives should be equal, and that to be a finite number. If both exist like differently, then obviously I cannot say that one speed is instantaneous. At one particular time, we will use, your physics teacher would have told you that at once instance you can only have one velocity, right? So obviously both the velocities, instantaneous velocities just before a particular time and just after a particular time should be 0, so should be same. And that is why we will say that LHD and RHD should be finite. Then we say that this function is differentiable at that point. Is the concept clear? Is the concept clear? Yes, Subodh. A very minute, right? That's what you're trying to say. Very minute. Everyone understood what is the concept of differentiability, guys? Hi, Ganesh. So guys, this was all about differentiability. So what in general I can say? I can say that your LHD should be equal to RHD. This is also called as what? LHD, left hand derivative and right hand derivative. If your left hand derivative, right hand derivative is equal to same, a finite number, then we say that the function is differentiable at that particular point. Okay, guys. Now let's take an example. One example I will take, and every concept will be covered, guys. Okay. Now also, guys, one more thing we will have to understand, that if a function is continuous, so let's suppose, guys, if a function is continuous, so if function is continuous, So it may or may not be differentiable. It can be differentiable or it cannot be differentiable, right? Or it can be. But if a function is differentiable, guys, hai na? If a function is differentiable, it has to be continuous, right? Because we told that differentiability ka condition was what? First, it has to be continuous. Remember? Because smooth tangent can only be drawn when the curve is continuous. So if function is differentiable, it means automatically it is continuous. Okay, guys? Fine. So that is what we have, guys. So if you draw the set, which one will be the superset? Obviously, continuity will be a superset, right? And differentiability will be some cases. So if a function is differentiable, I can definitely say it is continuous. But few functions can be continuous but not differentiable. Yes, fantastic, Sindhuja. Yes, hi Rani. Okay, so that is what we have to understand, guys. Clear? Very standard thing, because in the first slide only I told you that a function is differentiable if it is continuous and smooth. Smooth, we got that definition from where? Tangent, right? Tangent. And continuity to hona hi chahiye. That has to be continuous, no doubt about it. Now this is a very good example, guys, which I'm taking. So first what I'm doing is I will obviously calculate the LHD and RHD, but first I would like to check its continuity. So guys, if you look at the continuity, so let's suppose if I'm trying to calculate the LHL, let's check the continuity first. Check continuity. So guys, if I look at LHL at 0, what will be that? Limit x tending to 0 minus, and that will be x into e power 1 by x minus e power minus 1 by x upon e power 1 by x plus e power minus 1 by x. Okay, guys. So guys, what is happening over here is, that the thing is, here, if you look at it, this thing is tending to 0, right? This thing is tending to 0. Now, what do we do? 0 minus, right? So here you put 0 minus. So that means what? Negative 0.00000. So what will happen, guys, if you put 0, so negative 0.001, for the time being I'm putting it. So what I'll get, guys, am I not getting minus 0.00001? And this will become what? Minus e power 1 by plus 0.0001 divided by e power minus 1 by 0.001 plus e power plus 0.00001. Are you getting my point, everyone? So here, why did I do it? See, this is a finite quantity. Ultimately, the answer will come 0. Why? Because if you bring this down, so guys, if I divide by e power minus 1 by x, won't I get, let's suppose, can I say e power 1 by x divided by e power minus 1 by x minus 1 upon, also I can write this thing, e power 1 by x minus plus e power minus, so this will become 1. This will become 1. Are you getting my point, everyone? I am dividing it. Why? So here this will be e power minus 1 by x. So this will go as become 2 times, right? Isn't it, everyone? So this will be simply, it will be, you can say, if you divide by that, you will get 0 minus, then e power minus 2 by 0.001 minus 1 upon e by minus 2 by 0.0001 plus 1. Are you getting, everyone? So this thing, what is e power minus infinity? Because this is e power minus infinity, which is tending to 0, right? So 0 into tending to 0 by tending to 0. So can I say this thing will tend to 0, this thing will tend to 0? So it is going to be what, guys? 0 into minus 1 by 1, which is going to be 0. So guys, can I say LHL is 0? Right? Absolutely. I will say LHL is 0, and similarly your RHL will be 0, because in that scenario what we will do is, we will actually make this thing, if for RHL what we will do is, we will do limit x tending to 0 plus, that will be 0 plus into, we will do 1 minus e power minus 2 by x, right? because we'll divide by e power 1 by x in that scenario. Okay, so this thing will become what? This thing will become 1 plus e power minus 2 by x. Why we divided by the different thing now? Because this part will now tend to infinity 0. This part will tend to 0 because 0 plus is there, my dear friends. That is why e power minus 2 by 0 plus will be what? E power minus 2 into infinity, which is e power minus infinity, that will tend to 0. Understood why we did that, guys? So this part is coming as 0 plus into 1 by 1. Doesn't matter. This will be equal to 0 whatever be the scenario. Understood? The thing is, this might be a little bit changed when we calculate the differentiability. So did you guys all get the continuity part? It's like what I'm doing is, see, you will understand. Let's suppose if I have got infinity, or you can say, if you have infinity. So let's suppose if I have got infinity minus infinity. So if I have got here, see, this is because 0 plus, right? This will be what? 1 e power 1 by x minus infinity upon 1 plus infinity. So when we divide by that infinity cancels, right? So that is what we are trying to see here, guys. Because this was what? E power 1 by x and this was e power minus 1 by x. Now let's look at the differentiability part. The differentiability part is really interesting. So you will try to understand this. So guys, if I look at the LHD first, okay, let's look at the LHD. So guys, LHD, what I'll do is, I know the standard rule, that is not limit h tending to 0, f of, or else let's calculate RHD first. Let's calculate RHD. So a plus h minus f of a upon h, right? So guys, what is f of a plus h going to be? Limit h tending to 0, f of a plus h will be, in place of a, you have to keep 0, right? Because we are calculating at 0. So 0 plus h. So can I say it will be h into e power 1 by h minus e power minus 1 by h upon e power 1 by h, right? And obviously this is positive h, you know? So plus e power minus 1 by h. Now guys, what is happening over here is this part is what? H is tending to 0 plus. So this is infinity minus 0, right? Infinity. So you can say this is e, because e power 1 by 0.0001 is what? E power infinity, right? E power infinity will be infinity, but e power, try to understand, minus 1.0.001 will be what? That will be e power minus infinity, which is tending to 0. This thing is everyone getting or not? E power infinity is infinity, but e power minus infinity is 0. Okay, so this thing over here is like what? Your RHD is like, what are you getting? You're getting h and whole divided by h. Don't forget that. So this h and this h will cancel. So h and h is cancelled. Okay, we are getting, guys, infinity minus 0 upon infinity plus 0. So what is infinity minus 0 upon infinity plus 0? Just try to understand. Very wonderful thing we'll be getting. So RHD is coming as, guys, RHD is coming as infinity minus 0 upon infinity plus 0. So if you divide by infinity, so what will get? 1 minus 0 by infinity upon 1 plus 0 by infinity. Can I say this will be what? 0 only, and this will be what? 0 only. So can I say 1 by 1 is 1? Yes, 1 by 1 will become 1. So RHD is coming as 1. Understood? Now let's look into the LHD part. So LHD will be what, guys? LHD will be limit h tending to 0. This h is always positive. This is f of 0 minus h minus f of 0. Okay, f of 0 upon minus h, right? So f of 0 is 0, guys, right? That's why I didn't subtract it. F of 0 is 0 only. So what will happen, guys, if you put here in place of x minus h? So wouldn't I get something like minus h into, let's suppose I'll get e power minus 1 by h, and this will be what? Minus e power 1 by h and divided by e power minus 1 by h plus e power 1 by h. है ना? Because in place of x you have to keep minus h, guys. So that's why this became negative, right? This became what? If you replace x by minus h, so what will happen? Minus 1 by h, and that's why this became plus, and this became minus. And this is, that's why I replaced x by minus h. Understood? And overall, you have to divide by what, guys? Minus h, right? So minus h will cancel. Now, guys, this is what? Limit h tending to 0. Limit h tending to 0. So this is what now here? This is 0. This is infinity. So it is what? 0 minus infinity upon 0 plus infinity. Now when you divide by infinity, what are we getting, guys? Tell me. If you divide by infinity, we will get what? Limit h tending to 0. We are getting 0 by infinity minus 1 upon 0 by infinity plus 1. So that is why this thing is becoming 0, 0, and this is minus 1. थोड़ा सा typical था, right? Little bit typical. So LHD not equal to RHD, but still the function is continuous but not differentiable. Are you getting, guys? What I did is I'll just summarize this part a little. The summarization says that infinity plus 0 upon infinity minus 0 upon infinity plus 0, infinity minus 0 upon infinity plus 0 is coming as what? You divide by infinity, so you'll get what? 1 minus 0 by infinity. 0 by infinity is what? 0 only. You know? And this will be what? 1 plus 0 by infinity. This thing I am saying 1, like here. But when I have got, let's suppose, 0 minus infinity upon 0 plus infinity, this thing will change. When this will become minus 1. Clear, everyone? Understood? So that is why this function over here is not differentiable. This thing, if you understood, so most of the concepts are cleared, guys. So LHD is not equal to RHD. Got it, everyone? Okay. Chalo, guys. Now let's look into the basic standard thing. So if you look at the examination of continuity and differentiability of mod x at x equals to 0. So what will happen? So this is the graph here. Obviously, you will look at this graph. So after this, from mathematical terms, we can obviously derive. But from graphically, we can obviously see that this is the slope and this is the slope for the LHD part, which is this. So if you look at the slope here, this is 45 and this is 135, right? So LHD is tan 45 and RHD is tan 135. So LHD is what? 1 and RHD is what? Minus 1. Isn't it? Sorry, I just changed it. LHD is, you're going to be minus 1 and RHD is going to be minus 1. Understood, guys? RHD is what? Slope is 1 and LHD is what? Slope is minus 1. So that is how you are deriving it. Also, if you look at the graph, can I say f of x can be written as x for x greater than 0 and minus x for x less than 0. Now, guys, if you differentiate it, so obviously if you try to calculate the LHD and RHD using that thing, that is also fine. But you can obviously differentiate, right? So what will be f dash of x, guys? Just differentiate the numerator, upper part, 1 for x greater than 0 and minus 1 for x less than 0. So see here, guys, how easily we understood that. How easily I understood that this part is 1 and this part is minus 1. So LHD is minus 1, RHD is 1. So just see that LHD is not equal to RHD. Yes, Sindhuja. Isn't it, guys? Clear? So that is the reason why mod x is non-differentiable. LHD not equal to RHD. That's why this function is not differentiable. Okay. Now let's look into a very standard question, that is we have to examine this thing using the graph. Okay, so how do we draw the graph of sine mod x by whole mod? So guys, sine mod x graph everyone would have seen. What is the graph of sine mod x? Like sine x graph is what? It is like this. So sine mod x means what you have to do is you have to simply remove the left part and take the reflection of the right part. So sine mod x graph is like this, guys. And then this is like this. So it is smooth everywhere. Yes, negative part will be there. Negative part will be there. But the thing is, it is sharp point at this only one point. So it won't be differentiable at x is equals to 0. Understood? But I am talking about mod of sine mod x. So mod of sine mod x will be what? Okay, so if you do this, so what will happen, guys? Mod will be what? Taking the everything part up. And this also part will be what? It will be like this only. Right? Okay. So guys, you can see that at all integers, if you draw the tangent, so at all integers, the tangent is what? For this integral multiples of pi. So this was what? Pi, this is 2 pi, this is 3 pi. So what is happening? We are getting different tangents. Isn't it, Sindhuja? Yes. So we are getting different tangents, right? Before and after. Okay. Saurabh, it would be available. I guess there would be some issue. And then guys, if you do this again, you will be getting what? So at all integral multiples of pi, the function is what? Non-differentiable, right? So this will be obviously continuous. The graph is not breaking, but it would not be differentiable, right? So see here from the graph, we can definitely say that mod of sine mod x is continuous at all integral points, but not differentiable. Okay, so it is continuous but not differentiable at integral multiples of pi. Okay, chalo guys, we'll take up a very good question today, and then first we'll take up a question and then we'll move ahead tomorrow onwards on the questions of Indian interval and some standard problems asked in mains and advanced. So guys, this is the function f of x. So x square is ax plus b. F of x is x square and ax plus b for x less than or equal to x naught and for x less than x naught. So guys, the first thing is a function is differentiable. So can I say it will be continuous also? Yes. So can I say LHL will be equal to RHL? Yes. So that is a hidden concept which we have to apply every question. So what will be that, guys? Limit that is LHL will be equal to RHL. So LHL will be what? Simply put x naught here, isn't it? So if you put x naught, what will be getting? X naught square will be equal to what? Ax naught plus b. First equation from where we got? From continuity. Now differentiable also. So what is f dash of x going to be, guys? Differentiate the upper part. What do you get? 2x for x less than or equal to x naught. And if you differentiate this, you will get a for x greater than x naught. Yes, bindas. So now what we'll do, guys? Obviously, if it is differentiable, the LHD should be equal to RHD. So you just have to put it there. Hai? So you will put x as a directly now. So LHD will be put x naught 2x naught square, and that is going to be what? 2x naught square, and that is going to be what? A, that is nothing but my RHD. Got it? So A has come out to be 2x naught square. A has come out to be 2x naught square. So A is 2x naught. One second. Sorry, 2x naught only, not x naught square. We have to substitute in place of x naught. My mistake. So that is nothing but what? 2x naught. A is what? 2x naught. Now what about B, guys? How do we get the B? From this equation, if you put A as x naught, so you'll get x naught square is equals to 2x naught square plus B. So B will be minus x naught square. Yes. So B option is correct, where we are getting A is 2x naught and B is minus x naught square. Got it, everyone? Understood? So at the moment, wherever, so did you understand? Did I use any standard LHD RHD thing? No. Did I use f of a plus h minus f of a upon h? No. Why? Because that was not required. This part is smooth. This part is smooth. Whenever both the upper and down parts are smooth and continuous, we can differentiate it at the point of breakage. Understood the logic? This question of mod x also we were differentiating above. We were differentiating it below. Are you getting my point? So that is why the reason of that we are doing is because that is easily differentiable above and that is also differentiable down. Got it, everyone? Fine. Okay. So guys, there's a homework for all of you. So you can try this. We have to calculate the left hand derivative for this function. Okay, try this. We'll discuss this question in the next class tomorrow. Till then, everyone, thanks a lot for joining. You can just note down this question, guys. Quickly, you can take a screenshot also. A wonderful question. You have to calculate the left hand derivative. We'll start the class from 10 a.m. sharp tomorrow. Same time, guys. Thanks a lot. Do install the app. Take the plus subscription if possible and use the code AgeAlive if you've got it. Okay, guys. Thanks a lot. Till then, bye-bye. Take care, everyone.